talk a few years ago in Oslo called TDD, Whether It Will Go Wrong, which was really me raising the concern of, hey, I've been doing TDD for, at that stage, it was about 7 or 8 years. I think we're making a number of mistakes. That's proved very popular, but I felt that what I needed to really do was try and formalize the advice from that discussion in a slightly easier way for developers to actually work with. So I wanted to come up with really a set of fallacies and principles that I felt would help you do effective TDD. Okay, so this is just me. It's not very exciting, apart from the fact that it says that I am kind of old. But the point I do make is the point at the very bottom of this kind of presentation, which is, I've found over my career that speaking about topics has really helped me to formalize my thoughts, get them clear in my head so that I can talk to other people more clearly about them, and enabled me to meet a whole load of other software developers, travel around the world when we could do that once upon a time. And so I'd encourage anyone who's thinking about it, really do have a stab at it, present to your colleagues to start with, present to a local user group, and it really can be helpful. Oops. Sorry. Some of you may be .NET or Python developers. I work on an open source project to do with messaging called Brighter. There's a .NET version called Brighter, and there's a Python version called Brightside. We are always looking for users and contributors. Please do go and check it out. You can probably do a search for GitHub Brighter, and that will get you there. I think there's some links in the slide deck. We'll come to it later. If you want to get involved in open source, we're very, very welcome. I work for Just Eat Takeaway, and we are hiring. We have an office via Cyclum in Ukraine. So if you would like to talk about the opportunities we have, please use the email address, and there's a QR code. I think if we share the slide deck, you should be able to get hold of those. I will remind you of this kind of at the end. Okay, so there's a chance to work with people like me. We'd love to see you. All right, so we'll start talking about the fallacies and the principles that we should use when applying TDD. I've got a little section then towards the end of that. We'll talk about the clean architecture as a way of helping us do TDD successfully. And then we'll have kind of a summary, and then I will do questions at the end of it. Okay, so let's talk about the fallacies of TDD. So this, to me, is kind of the big fallacy, the one that, if you like, is at the heart of all the problems we experience with TDD. And that's this seemingly simple idea that developers write unit tests. So let's take a step back and kind of see what we mean by that. If I look at the definition of unit testing in Wikipedia, this is what it has to say. It says, to isolate issues that may arise, each test case should be tested independently. Substitutes, such as method stubs, mock objects, fakes, and test harnesses can be used to assist testing a module in isolation. So what does that actually mean? Well, the classic way we would do unit testing is we would say, as a tester, here is a module that the developers have finished working on. I'm going to treat that as a black box, and I'm going to test it via whatever interface that module offers me, an API, something else. And what I want to do is understand whether there are any defects in that module. So I'm going to isolate it from any other modules in the system. And if, in order for that module to work, it has to make calls to other modules, I'll use some kind of substitute, a mock or a fake or a stub, to represent that, such that I know that actually failures are due to this module and not another module. I've replaced those with these stubs. And then what I do is, once I've tested those modules, I need to say, okay, what happens if actually I replace the fakes with basically a real module? So I test a couple of modules talking to each other. And then I say, okay, because given these modules are both passing all the tests, any failures are now the integration between these two modules. And I get up to system testing, where I test everything. This is kind of like how classical testing always worked, right? And isolation or defect isolation was a key idea. This idea that I want to isolate any defects I have to a given module, and then I can tell the developers, hey, there's a problem in this module, please go and correct it for me. Excuse me. And what happened was, early on in the history of test-driven development, people began to look at how this classical testing model worked and say, well, we should be applying that to test-driven development. So that must mean that I need to isolate my module. Quite often in OO terms, we thought of the module as being kind of a class. And that means I have to replace any dependencies it has with some kind of substitute. Sometimes we refer to that as a test double generically, but mocks and fakes, in order to make sure that when you do your TDD practice, we know that any failures come from that individual class or module. And this led to a path which ended up in what we sometimes call need-driven development. And need-driven development says, here's how I do my development. I start out usually by writing a test at the kind of outer level of my system that says, here is some kind of behavior that I want. And then I go and implement that particular behavior that meets that test. And as I begin to implement that behavior, I come across collaborators, other classes that my class talks to. And I do one of two things generally. I either, before I sit down and do my testing, I've done some design. I have an idea of what my class hierarchy I'm going to use to implement my solution to this problem looks like. I may have sat down with other developers and used a technique like C cards. It's where you get a card, you write the name of the class on the front, you write its responsibilities and its collaborators, and you essentially play a game of walking through scenarios, saying, well, I'd handle this, you handle that, and you move around figuring out a class structure that lets you meet a requirement. So if you do that, what you can do then is say, okay, I'm going to need to inject mock that represent those collaborators into this class, such that effectively I can replace them and I can isolate just the code in this particular test. The other alternative, what happens is as you're actually going through your implementation, you say, oh, there's quite a lot of stuff I need to do here. I think that's going to be a collaborator. I'm going to basically write a mock now. And as I build up that history of mocks, they will effectively form a specification for what those collaborators need to do for me eventually. So you're either doing some upfront design or you're effectively discovering what collaborators do. That's a way that many of us have been taught to do test-driven development in the modern world. Okay. There are some interesting consequences to that, though, right? So when we think about the test, we can think about the test as being something that says, you have a contract, and I'm going to verify that contract. And here, interestingly, in this kind of test, where we use a mock or a fake, and we set it up in the test, we call it, and we quite often verify it was called in a specific way, we don't only test the contract of the class under test, but we actually test its interaction with all its collaborators. So both of those things become part of our test. So back in about 2007, I've been doing test-driven development for about 3 or 4 years. So I was lucky enough to start very early on in 2003 and 2004. So in London, where I'm based, we used to hold our meetings quite close to a group called Extreme Tuesday Club, who were all very interested in the emerging ideas of extreme programming, test-driven development. One of them came to our meeting and preached the good word of test-driven development to us. And one of the problems I hit was this. Our model was very much to mock stuff. So we get a class and we'd say, any collaborators of that class, I need to mock them. So we would tend to inject those then in via the constructor of the class that was actually under test. I was using a strongly typed language, C#. So what I would need to do essentially was create an interface that represented the behavior of that collaborator. And then I could essentially replace that with a concrete implementation in the system, but I could replace that with a test double for my tests. One of the early things we noticed was, wow, we've now got a lot of dependencies for any given class. We're no longer just using new to create an instance of that type inside our constructor, but passing it in. Now, if I, writing my class, have, say, two dependencies, A and B, and let's say A has two dependencies, C and D, and B has two dependencies, E and F, and each one of those has two dependencies in turn, we rapidly build up quite a big graph of dependencies from my class. Now that gets quite complicated then for us to instantiate, because, hey, I've got to figure out the whole graph of objects and maybe some of them are shared, etc. So then we came up with inversion of control containers, right, to do the dependency injection for us. So we also started to have to use IOC containers because we wanted to build this graph to present the object at runtime to create instances. As well as DI containers, the other thing we began to notice is that our tests were very fragile. They had what we called behavior sensitivity, in that because we're not just testing the contract of our class, but we're testing all of its interactions, if we change any of those interactions, then our tests break. When we began to worry that we have what was called overspecified software, in that we only know about essentially our contract, but about our implementation details. Testing all of our interactions essentially meant that our tests have become coupled to the implementation details of that class. We had to understand the implementation details to understand the interactions. And that isn't necessarily a positive thing, because it means that my code is fragile. Whenever I try to change my code, which is under test, I break a whole load of tests. So the principle we should actually be following is developers write developer tests. Let's talk about that instead. So interestingly, the key book that introduced a lot of us originally to test-driven development was by Kent Beck, and it was called TDD by Example. And it's worth noting that Kent and others in the kind of extreme programming community have been practicing TDD for quite a while at various places like the Chrysler Corporation in the US, and began to document what they've been doing. So it's not a new practice to them, they're quite experienced. And Kent says, oh, I tend to call them unit tests, that what we're doing in TDD, but they don't actually meet the definition of unit tests very well. And in fact, within the book, this sentence is the only mention of the word unit tests. But also there's things like he called one of the first, test frameworks are called JUnit, right? They're doing this TDD with. So there's a bit of confusion. But he's very clear that the tests he's discussing in his book do not meet any of the characteristics of unit tests that we just discussed originally. This idea of isolation, this idea of modules, this idea of black box testing. That is not the intent of unit tests. One of the other key players at the time is Martin Fowler. And Martin Fowler writes an expansive book on refactoring. Now, refactoring is covered in Kent's TDD book as well, and Martin goes away and writes a whole book on it. And Martin defines refactoring as this. Refactoring is a change made to the internal structure of software to make it easier to understand and cheaper to modify without changing its observable behavior. Now, most of you probably know that when Kent talks about the TDD cycle, it's this model of red-green refactor. I write a failing test. So tests don't have tests. So the first thing I need to do is check that my assertion will break until I write code. So I write a failing test. Then effectively I go to green. So I make the changes required to pass. And generally the suggestion is I don't write good code at this point. I effectively write whatever code I need, copying from Stack Overflow, copying, cut and pasting code from other things I've written previously, in order to essentially discover the algorithm change that makes this test pass. Then in the refactoring step, I go ahead and I make good code, right? And Kent's point was, we often find it very difficult to do two things at once, to both solve a problem and to write a good solution to that problem. So what we really need to do is solve the problem first and then write a good solution. We prevent lots of problems with over complexity if the first thing we do is write the simplest possible, just line after line of code solution we can get to the problem, because then we know what we have here is the scope of the problem and no more. Right? But the problem with this is that effectively, if we have a model that says, I'm going to basically refactor as my third step, if I have introduced mocks and I have lots of interaction testing as well as contract testing, many of my refactoring steps will break more than just the test that I'm currently working on and the behavior I'm currently working on, but it will break many of the tests. And it will break many of those tests quite often, not because I've genuinely broken what this module under test is doing, but just I've simply made different decisions about how I want to interact with other classes or collaborators. And this is this key idea that we begin to basically get away from us. This idea that if I don't change the contract of the thing under test, its observable behavior, I just change implementation details, then none of my tests should fail. And my cycle, red, green, refactor, should therefore be quite fast. But in too many cases, by focusing on a unit testing model, what's happening is we're not getting red, green, refactor. In some cases, we don't even get refactoring. And that's because if we've done that CRC card model, the problem is we've tended to have to do a lot of design up front. We thought about our model, we've sort of done everything up front. What we haven't done is designed that model in response to the code, the requirements that we have. What we've done is actually sat down and figured it out ahead of time. Then we've written the code. And essentially, we've made the code, we filled out those class structures that we've pre-decided, right? What we really want to do with test-driven development is explore and only really write the necessary code. So I really want to start with a contract that says, hey, I need to fulfill this contract. I begin exploring how to implement it by wrapping the observable behavior of that contract in tests. And that's not what's happening when we basically use a unit testing approach. And Kevin's very clear, right? If a program's behavior is stable from an observer's perspective, then no test should change. TDD is most definitely what we think of as a contract-first approach to design. The idea is I am sketching out the contract that a class is going to expose to its collaborators, and provided I don't change that contract, I shouldn't have to change any tests. So that means I can go away and do this red green refactoring step, writing a whole load of script-like code that just basically figures out the algorithm, and then go and do refactoring much more successfully, because I can change those implementation details as much as I want. And later on, if I discover this algorithm is a bit slow, etc., and I want to use a new faster one, I should be able to go and change that without any of my collaborators breaking, because my contract remains the same. And again, Kent said, tests should be coupled to the behavior of the code and decoupled from the structure of the code. And I'm seeing tests that fail on both counts, right? So by that we mean effectively they should be coupled to the contract and not to the implementation details. By the implementation details, we mean we get coupling when we have mocks, because those mocks effectively reveal the implementation details, and we couple to that interaction. And in fact, Kent's pretty clear. So Kent had a meeting with DHH, who's behind Ruby on Rails, and Martin Fowler, after DHH tweeted about, not wanting to do TDD anymore. And really, DHH, it became clear, was following this very mockist approach to doing TDD. And that video is a link here, but in that video, Kent says, my personal style, I just don't go very far down the mock path. The test is completely coupled to the implementation, not the interface. Of course, you can't change anything without breaking the tests. So, this is, Kent was explicitly rejecting, this is about 2012, 2013, I think, this whole model where effectively we have this, mock everything kind of approach towards testing. And indeed, actually, it's even in TDD, by example, where mocks are mentioned, they are rejected in this role, right? And we'll talk a little bit about where Kent actually intended for you to use mocks. But yeah, don't try and isolate the SUT. It is not you are not doing unit testing, and you are not trying to isolate the SUT from all of its dependencies. You are trying to check the contract that you expose. Right. Okay. So unit testing is defined this way. Failure of a unit test shall implicate one-on-one only unit. And that's why it has this notion of using a module and replacing its dependencies with fakes. Okay. That's its fundamental principle. What we do in TDD is usually called a programmer test or a developer test sometimes by the community. Failure of a programmer test under test-driven development implicates only the most recent edit. So the way you do defect localization when you're doing proper TDD is you say, well, I have a test suite that's green, I'm going to go and make a change. First of all, presumably I write a red test to prove effectively that something will be broken. I'll go away and write something green, and I'll then go and do my refactoring. If in my refactoring, I make a change and tests go red, I know that whatever lines I just refactored broke the code. That's where the error is. It's in those lines of code I just wrote. And that's why, if you also find that correlates to this, many advocates of, say, XP will advocate making small changes rapidly. Because each change I make, if it's only 4 or 5 lines, it's usually pretty obvious to me in that small change what caused things to go red. Things will go red and I'll go, oh, okay. So I won't even sprint the debugger. And I get out of this debug loop because in most cases, I don't even need to go into the debugger to figure it out. Now, some of the hardcore advocates around TDD in this model would say, well, at this point, if effectively you can't immediately spot the error, you revert the change out in source control and you try making it again, right? You say, okay, abandon that refactoring. Let me think about what I'm doing and figure out basically a different way of solving it that won't break. I'm a little bit more relaxed than that. I say, sometimes that's a good change. You've obviously made some stupid mistake. Hey, I'm probably going to get help if I spin up the debugger to figure that out, right? But your goal is to have a small amount of change. The small amount of change is where the defect's going to be. I then go and look for it. And in theory, right, software is deterministic. My code can't break unless I change something. So it's that change that you're looking for to be the source of the problem. That's the fundamental principle behind TDD. And in fact, if you go to the C2 wiki, where a lot of the kind of knowledge of the extreme programming and TDD community is actually preserved, you can see this definition of TDD. Test-driven development produces developer tests. The failure of a test case implicates only the developer's most recent edit. This implies that developers don't need to use mock objects, but they're cut up into testable units. And it implies that the developer may always avoid debugging by reverting the last edit. So the key idea basically is program or developer tests, not unit tests. TDD essentially is a process of continuous discovery where effectively we are continually making small changes to try and implement some requirement. We don't need to use mocks to isolate the module, the package, the class, whatever it is as our unit under test, right? Because effectively, we don't need that isolation. The defect localization is coming from the most recent edit. Now, there is a place for mocks in test-driven development, because Kent does talk about mocks in his book, and he's very clear about when we use them. So tests should be fast. Tests should be fast because we don't want to interrupt the flow of a developer who's writing a test to make some small change to the software, making a small change, writing another test, make another small change. We don't want to interrupt that flow too much. We want to run all the tests, we want to run them fast. To run tests fast, one of the ways we do that is we run tests in parallel. If I want to run tests in parallel, the one thing I can't have is shared state. It's called a shared fixture, because then two tests, both addressing that shared state, will likely interfere with each other. So if there is isolation in test-driven development, it's isolating one test from another test. And that is where effectively we may need to use some kind of mocking to replace a shared fixture that we can't design out to allow tests to run in parallel. Typically, most of our shared fixtures tend to be IO based. I'm talking to a file. I'm talking to a database. I'm talking to an external system effectively to get results out of it. On the latter point, and even on databases, we also get the other reason it's useful to mock IO, and that's because of speed. Because it's very slow quite often to make that network call, make that call to the database. And therefore, essentially, because we want our test to run fast, we quite often take the strategy of saying, let's mock out that IO in order to speed our tests up. And finally, in some cases, we mock for fragility, where essentially there is a non-deterministic response likely, which means our test might break. So one typical one is time. If I ask the clock what time it is, I can't determine that ahead of time for my test. So typical use of mock is to basically have a clock, which effectively the concrete implementation gives you the time as established by your system, but your mock version gives you basically a fixed time that you inject beforehand to make it deterministic. But effectively shared fixture, speed, and fragility are the only real reasons you should be using mocks. Otherwise, you should not be isolating your classes. You should be doing things up. Right. Now, the only other thing to think about is that we may want to have valid reasons for doing dependency injection. We may want to basically work across layer boundaries. We may want to inject some kind of strategy into our class. So we're not saying you can't use any form of dependency injection, but we're saying dependency injection is not driven by a testing requirement. And indeed, quite often you find once you approach tests this way, that your DI requirements reduce to the extent you don't even need an IOC container anymore. You can just do what's called poor man's DI, which is you start the composition, you new things up and pass them to things that you're creating. The second idea is that the fallacy we want to talk about is the trigger for a new test as a new function. So very typically, what might happen in practice of TDD is we think, I want to write a function or a method on a class. I need to get it under test for it to exist. So I'm going to write a test around it. And it's kind of quite logical that this might be how we think. When we think about functions, functions have some preconditions, things we want to be true before we call them, and some postconditions. What's the state like after we call them, right? And effectively, we can think of the function as a transformation that transforms between state before to state after, right? And that actually models pretty well with testing, right? I've got some setup, I run the code, and I make some assertions. So a function seems like quite a natural point to get that working. And the implementation is simply filling in the algorithm that function needs. So that tends to lead people thinking, well, the system under test is kind of my function, right? That's what I'm actually working against. And that that's a dangerous kind of pattern of thinking, right? Because it tends to say, well, what we're trying to do when we start testing is confirming this method does what I expect it to do. I call it, I pass it these values, I get this response back, right? And it leads to ideas like 100% test coverage, saying, hey, essentially what I would like to do is have 100% test coverage, so I should test every function. Sometimes that even leads to people thinking, well, how do I begin to test functions that are actually not visible? In other words, they are protected, private, whatever, depending on the language is the system you have for hiding stuff. How do I test those, right? Which would seem to be problematic because that is also an implementation detail. It also tends to drive us towards saying, well, what test that everything works? Given that I've effectively got these tests around individual functions, how do I know that the behavior that the user wants from the system is actually passing? How do I, where is that behavior expressed? That tends to lead us to think as well as unit tests and integration tests. If I'm following the bad model, I'm going to need acceptance tests. Because the acceptance test will tell me that all these functions, when working together, actually give me the behavior of the system. The problem with this approach is that quite often when I come to look at my tests under this model, it's very difficult for me to understand what they're for. I find that I have a method, I pass in some values to it, I assert that there's a transformation to some things after, but I don't really have any context. I don't know why it's important that when I pass foo and bar into this method, I get baz back out, right? Maybe I can just about infer that from the name of the function, but it can be difficult to read my tests 6 months later, even if I wrote them, especially hard for somebody else to read them and understand what was I doing here? What is the reason why when I pass foo and bar, I get baz in context of what the user needs? And the reason this can be a bit of a problem is when we think about what, things like extreme programming were promising, one of their promises was this idea of the executable specification, right? This idea that I wouldn't need to document my code anymore because test-driven development would basically mean my tests were a documentation of my code. The contract would be fully explained on how to use it with examples. And everyone knows examples are much better than, all these words describing the behavior. I can really look and see exactly what I mean, right? And advocates of XP said, we don't need all that documentation. You can just go and read the tests. The tests clearly explain how to use the software. And of course, people laughed at this. It's kind of like, well, that isn't true, right? I go and read my tests, can't understand a word of what I'm supposed to be doing, right? So where did this dream come from and why is it dying at this point? So the actual principle you're looking for here is the trigger for a test as a new behavior. Okay. So this is one of the problems. So Kent's book TDD by example takes examples effectively of doing TDD. That's how it basically explains how TDD works to you. And one of the things it takes as an example to work on is we need to be able to add amounts in two different currencies and convert the result given a set of exchange rates. So nothing here says I'm testing a function, right? That's not the requirement Kent's got. Kent's got a requirement basically that he needs to implement. He's saying, given a set of exchange rates, when we add amounts in two different currencies, then we convert the result to one of those currencies. And if I shuffle that around, you can rewrite it like this. Given a set of exchange rates, when I add two amounts in different currencies together, then I get a result in the first currency. Some of you may be familiar with the idea of given, when, then, popularized by BDD, by Dan North, okay, which kind of says, given the set were before the test, when I exercise the behavior under test, then we expect the following changes. But what's clear is this is not really a BDD innovation, right? This is TDD as it was meant to be practiced originally. This is exactly what Kent's doing in his book right from the beginning. He's effectively writing given, when, thens. So Jared Mazaris in a book called X-Unit Test Patterns, one of the things he points out is there's this thing called the four-fold test model, which exists from day one in X-Unit tools, which is setup, basically. In other words, the given. exercise, generally, mark an attribute as test or something, when, verify, in other words, make some assertions, and then tear down, right? Move everything back at the end. But given when then is really just a variation on that, as is Bill Waite defined it as act, arrange, and assert. Okay, well, probably arrange, act, and assert, actually. But effectively arrange basically the things that the preconditions I need to carry out some action and then assert. But it's this behavior that we are defining that is the focus of our testing. That is what I'm testing. Given a set of exchange rates, when I add two amounts in different currencies together, then I get a result in the first currency. And the reality is that might mean I decided the implementation of this that I'm going to express is a method on a class which effectively says add, which basically takes a money object and adds on the money object to it, right? And so it may look a lot like I am testing a function that takes a money object, right? But the key idea is what I'm testing is this behavior. That's the concept I'm expressing. In fact, Dan North, in the original blog post, which gave rise to the term behavior-driven development, said, I found the shift from thinking in test to thinking in behavior so profound that I started to refer to TDD as BDD, or behavior-driven development. Now, it's important to recognize that at this point in history, BDD is just another name for TDD. It's a renaming of TDD to get people learn to practice it, to focus on it as a way of expressing behaviors, not tests. Dan has spotted this problem that later we fall into, that if people start thinking about tests, they start thinking about unit tests, integration tests, system tests, they start thinking about mocks. They start pursuing that classical test after model is what I tend to call it, basically, of testing, right? And that TDD, which is a technique for exploring requirements, requires a different way of thinking. Now, I want to point out at this point that I'm not necessarily in this talk advocating BDD as it exists today. BDD today is a quite different practice to TDD, which is what I am advocating, and I don't like many of the directions BDD has gone in. But I think the original observation, the original blog post by Dan many years ago that said, hey, TDD is about behaviors, not about basically unit tests, is key to understanding the direction that was successful with TDD and the direction that basically went wrong when we introduced test after ideas like unit and integration and system. And so really when we think about TDD, what do we do? Well, the next test you write in TDD is the most obvious step you can make towards implementing the requirement given a use case or a user story. And remember, we try and move in small little movements because each one of those gives us defect localization to a small amount of code we've written to get that test to pass. Okay. And usually the biggest question people have with test-driven development is, well, what test do I write next? And the answer is, whatever makes the smallest change that you can to what's under test towards basically implementing your overall user story. Okay. And the idea why smallest change? Because we don't want to write a speculative code that we don't need. Okay. And so the use case or user story is basically how we capture those requirements, right? So user story is the modern agile version. Use case was slightly older, but they really much amount to the same thing. It's just that the user story defers the conversation about the detail until close to the time of implementation. And the acceptance criteria we write for use cases or user stories are what effectively form the requirements for TDD for us. One question, of course, is, well, if TDD says I'm the thing that basically expresses the behavior of the system from the user's requirements, what are acceptance tests for? And part of that, we'll come back to that. Okay. Another key thing to note is when we are in the refactoring step, if what we do is take, 100 lines of code we've written to express some algorithm, and we then say, well, that's too long, I'd like to basically use some simple refactorings like an extract method to express intent. In other words, take this block of code, take any comments I've got explaining what it does, actually create a function with a name that expresses that clearly and kind of section it off. Remove duplication is the other key one, right? And duplication is duplication of knowledge. These two things both know how to do the same thing. Only one place should know how to do it. So effectively, I can remove duplication. And as I do those steps, I may be creating new methods. I may even be creating new classes, but they are implementation details. They are not part of my shared public contract, and they do not require new tests. Refactoring, by definition, is a safe move that I can make that causes a change that won't break tests. Okay, so it's a safe change. It's a safe change. Tooling will do it for you, right? It says, take these lines of code, put them inside a method, give parameters basically effectively to that method and give a return value. It is safe. You can make that. You don't need new tests around it. And don't forget, you've got a test covering it right now, which is the original test that you wrote to go green before you started refactoring. And if you're not introducing new public behaviors, you're only changing your implementation details, you do not need new tests. And the advantage of that is I can then go and change those implementation details at will, provided I preserve the contract. It doesn't matter that I decide, you know what, this needs more classes, I'm going to introduce them. Or this needs less classes, it's too complicated, I'm going to take some out, right? So you don't introduce new tests at that point. Remember, refactoring is changing implementation without changing the behavior. Now, the implication, obviously, these details are not exported. If I do export things, I'm essentially saying there's a new behavior required on the contract. And that implies there ought to be some tests around it. Okay. All right, that's that. Okay. All right, so we deferred this little particular question while we had that. And this is the idea, the third fallacy is customers write acceptance tests. So once upon a time, we had this notion of functional or customer tests. Customer in agile or extreme programming referred to the team's expert on the requirements. And nowadays, really quite often thought of as the product owner. We don't tend to have the expert customer in the same way. Scrum kind of won the naming convention there. But the idea is essentially that this idea was that basically they would define the acceptance criteria for a user story. And hey, if they were going to write the acceptance criteria for the user story, could they write those in a way that essentially was directly executable? And so we've got this idea of acceptance tests from this idea that essentially the on-site expert who could answer questions would effectively be able to write a script that we would exercise. So originally there were tools like Fit and Fitness, which were based on HTML, then wikis, and were kind of table driven. And later we got this whole aspect, created a whole family of tools, particularly around basically Gherkin language DSL syntaxes. Okay. There's an interesting problem though, right? The first thing we might think about before we get into some of the detail is, but hang on, if we just established, Ian, earlier on that TDD is testing the acceptance criteria on user stories, why are we doing it again? But it's more detailed than that. So James Shaw, who this quote is from, is one of the creators of FIT, one of the very early functional testing or acceptance testing frameworks. And he said, there are two problems. Customers don't participate, which eliminates the purpose of acceptance testing, and they create a significant maintenance burden, meaning that acceptance testing isn't worth the cost, and I no longer use or recommend it. What does it mean by that? Well, the first thing is essentially customers don't participate. So in all my experience of using tools like Fit or Cucumber, the thing I discovered was customers wouldn't write tests using the DSL or the HTML framework. They would occasionally, if I literally stood over their shoulder and made them do it, but otherwise the developers wrote them. When the developers wrote them, there's an interesting question. If my developer is writing this kind of DSL style test, and I'm then regexing that, turning that into essentially something that then drives my actual underlying code, and often with a lot of complexity because changes to those basically tests are very hard. They require rippling out. I end up with a significant maintenance burden if I don't define some kind of DSL. That means I can reuse stuff, etc. If developers are writing them, well, why are we bothering to do that? The DSL is just a burden, right? The DSL is between me and writing those tests in the same programming language I'm doing the implementation in. The whole point about TDD using a kind of XUnit framework that's written in the same language you're using to do implementation is to lower the cost to the developer of context switching. But I've created that context switching for them if they're the ones writing the test. I even used to find it hard to get developers, to get customers to read the tests that you've written in Fit or in Cucumber. If they're not even reading them, they're just writing the acceptance criteria in a Jira ticket, I've really got zero value because the developers don't really want to read them that way. The second thing is that the typical way that we tended to basically write these was that we'd end up writing a test first to define the requirements, and then you kind of drill down, right? You then go and write your unit test to implement it. When you've got all those to pass, this test would go green and would be done. But that would mean that at any given point in an iteration, some of our tests in our acceptance test suite were read because we were implementing, not read because something was failing. That tended to mean developers would usually say, well, the tests are read in the acceptance test suite, probably because someone's working on it. And so they'd ignore it. And so at the end of the iteration, we then get this scramble to get the acceptance test to pass. We pushed ourselves back into a waterfall development model where we're effectively doing testing at the end because we didn't basically trust during any part of the iteration earlier that the tests were genuinely giving us a view whether software should be green or not. So they're highly problematic. But overall, I think my biggest concern about them is that because of their existence, they almost force us into a model where we say, well, TDD doesn't deal with acceptance criteria for the requirement, therefore TDD must be doing something else. Oh, hey, it's testing these methods, it's doing units, right? And it becomes a self-fulfilling prophecy, right? We built unit testing, therefore we need ATDD. We built ATDD, therefore we need unit testing. This whole thing becomes circular, and you could simply break it, like Alexander with the Gordian knot, right? You can chop through the whole thing and say, you know what, TDD does all of it. TDD does acceptance criteria, TDD tests the behavior, TDD basically is not isolated by units. I'm done, I need one tool, it's simple. And I think that's the problem. We've overcomplicated this whole space. And if you work by just using TDD, you simplify and reduce the cost significantly of getting things under test. I'm going to talk about this one saying effectively long red bar. Okay, so our principle should be that customers specify acceptance criteria. And James Shaw again, customers illustrate their descriptions with concrete examples. Programmers use these examples to guide their work. Sometimes programmers use the examples directly in their tests. More often, programmers use the examples as a guide, writing a multitude of more focused programmer-centric tests as they use TDD. In other words, you and the customer, the product owner, sit and discuss what the acceptance criteria is as part of the elaboration of the story. You write those down somewhere, and you use those to inform how am I going to do my TDD. Sometimes this is known as example-driven development, but really example-driven development, like BDD, just another name for doing TDD right. Oh yeah, and obviously, basically, one of the advantages of this is we tend to get self-documenting code. Right? We tend to hit that thing we basically at some points may have mocked as impossible, the idea that our tests would document our code, because if our tests are based around examples of how it works, then actually they do become much easier to read usually, and they do become much better as a way of saying, well, how do I use the code to achieve what I want? All right, let's look at our next fallacy, which is it doesn't matter if you test first or you test last. Okay. So test after or test last To me, I define that as a development process where we execute unit tests after the development corresponding units is finished. So unit testing, integration testing, and system testing are, for me, parts of the test after practice methodology, not the test first practice methodology. Okay. So essentially it says, well, the software's already been written. I want to basically do this unit integration acceptance testing strategy. I have done most of my design up front. In order to do test after, I've designed before I do testing. Okay. And I may do design before I write any code because I want to communicate that design with other developers on the team. So I may have used CRIC cards. I may have used UML, but generally there's a design and I'm now validating that design. That's a long feedback loop. With TDD, what happens is I have some acceptance criteria and I begin to explore how I implement the contract for that. And what I do is I make the smallest step possible towards implementation of the contract and I test that and see if that design is good. I make another small step and I test that and I see if that design is good. I make another small step and I see and I test that design is good. With test after, I make my design, 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 I test it. You are implicitly working in a waterfall style. You are not working an agile approach when you do test after, because you have significant risk that what happens is you get to the end and your testing tells you your design doesn't work and you have to basically re-engineer your design, right? You can't really refactor at this point because probably your unit testing strategy means that your implementation details are baked into your tests. So you've got to re-engineer all the risk that it entails. And the problem you hit quite often is because that's risky, you try and hack the existing code to fulfill the requirements rather than redesigning it. So you end up with actually a poor design for the genuine requirements. The other problem is that you are engaging in speculative code. Right? You're saying, well, I think that I need to implement all this design to meet the requirements. But because I'm not driving from the requirements, I quite often usually introduce a whole load of things saying, oh, there's probably an edge case over here, I'll add that. Or someone's going to need this at some point, so I'll add that requirement in, right? And you write all this additional code, sometimes with a really good intention of saying, you know, someone's bound to ask for that. I better add that code in, right? People are going to look at me afterwards and say, wow, he was able to implement that new requirement so quickly. And you're thinking to yourself, that's because I guessed it was coming and I'd already done the work, right? But the reality is usually you're wrong. You're not wrong always that requirement is needed, but you're quite often wrong that essentially in the detail, which means you tend to have to rework it. The other thing that happens is that requirement never emerges, but I've paid for it. I've made the company pay for a requirement they don't actually need. I've wasted their money. And many of you have had the experience of basically even at some point, you know, coming across some code and you realize there's a bug in it because you decided, oh, I want to up the test coverage. Let's get that code to run. Wow, there are bugs in this code. And then you realize it's never run. There's code in this code base that has never been executed in a production system because no tests prove that we were executing it. When we add the tests at the end, we tend to test, hey, what is the behavior I need? There's quite often whole paths in that code which are not under test, and I say it's a coverage tool. And the production system never touches. Doesn't ever execute that, only a test does. Right. We want to avoid that kind of model. So we should only write production code in response to a test, right? Now we'll caveat that in a second about what basically kind of tests we should be writing and how we do testing, but really we should only be writing production code in response to a test. We should only be writing a test in response to a requirement. And if we follow that simple set of rules, right? Production code requires a test requires a requirement. There's a straight path between a user wanted something and I wrote some code to implement it. Okay. I don't have speculative code anymore. Right. I also if I basically think there is some criteria and it's unclear, I can't write the test, have a prompt for a conversation with the product owner to say, exactly how does this work? I can't write the example for it. Therefore, I don't really understand it. Therefore, I can't write the implementation. You're working contract first with TDD. You're establishing the contract. In order to establish the contract, both parties need to be involved. Person asking for it and person implementing it, right? Okay. Ken Beck said, you need a way to think about design and you need to think about scope control. That's what TDD does for you. It gives you design. It's a contract first approach through testing to understanding what is the design we need to implement this, and it is scope control. We don't write code that is not needed by the requirements that we have. Okay. That naturally tends to lead to this idea. We want 100% test coverage of your code, and that would seem quite obvious, right? As Kent Beck says, TDD follow religiously should result in 100% statement coverage. I haven't ever written a statement that was that wasn't in response to a requirement. I haven't written a test that wasn't in response to code, wasn't in response to a test, and no test in response to a requirement. Therefore, all of the code that I write must be covered by a test, because I didn't write code that wasn't necessary for a test to pass. That would seem I must succeed at this, right? I must succeed at that. Only speculative code or untested branches during refactoring can cause me a problem. And hey, my code coverage tool is really important to me during refactoring, because it says, hey, did I introduce branches in the code that weren't covered by a test? If so, I should probably figure out what would force that branch, figure out I'm missing an example or some acceptance criteria, go back essentially and introduce basically a new test, and now I can make that refactoring with that branch in it. But actually, good teams doing TDD have suites with less than 100% tested code in it. Why might that be, right? Why might that be? And the answer is really that not every of your code is suitable for using TDD as a test strategy, as opposed to other test strategies, right? Okay. So at least this principle, really, which is more important, is not all of our code should be driven by TDD. So what's TDD good at? TDD is really good at providing with fast binary feedback. In other words, it's fast. I can run my whole test suite very quickly. I've mocked out all the IO effectively, etc., and the slow stuff, and I get red, green, passes, fails, binary. Really, and that's nothing is more certain than binary feedback, right? It either is good, it works, or it does not work, and I get a clear answer, right? If fast binary feedback is not the most useful way to get to an understanding of whether what you're writing is correct, TDD may not be the solution that you need. Okay. Some typical examples: visual output, right? TDD is not great around visual output. Why? Generally, I have a requirement written by a UX designer, so I have an upfront requirement. There's no exploration of contract with TDD. I'm not exploring, should I have a button? Should I have a field here you enter? Right, I'm not exploring that contract basically from the requirement. It tends to be, it's visually designed. Once upon a time, maybe we just got a set of acceptance criteria from the product owner saying, a field with this, a field with that. So maybe that was almost TDD worthy. But nowadays, most people get a UX design that gives you look and feel you have to implement. They're fragile and they're slow, right? We tend to spin up basically some kind of driver that drives effectively a UI. Sometimes they hook into things like training hooks in the operating system for recording training demos and stuff like that. And if you run suites of Selenium tests or other testing suites, they're often very slow, and they don't give you binary feedback very easily, right? They don't really tell you exactly that effectively that this change that this particular test passes. They quite often give you mixed feedback on things because the UI has many elements on it, right? Parts of it fail, parts of it succeed. So I tend to have to go and investigate quite a lot and figure out what went wrong. Typically, exploratory testing is a better model. Implement the UI, get it working as a developer by basically, just running it continuously. Yeah, I spin it up, I run it, I look at it. Is that right? Okay, that's the fast way to get feedback. I spin it up, I run out of types and values in. Did that work? That's the fastest way to get feedback. and then I pass it to a QA and they run it, right? Running it and typing stuff in is usually the quickest way with visual output to get good feedback. So don't do TDD against it usually. Spikes or prototypes, other throwaway code. The spike itself is how I'm getting feedback. I'm doing some exploratory learning by figuring out how I do something. TDD is not helping us at this point, right? I don't really have a requirement other than basically learn how this thing works. Okay. Integration. So even in TDD done right, okay, I've got this IO stuff, which I basically mocked out. And later on, I want to implement a concrete version of that IO. In a lot of cases with IO, I'm just using a ORM or a lightweight ORM or some other kind of database framework, or I'm making a call to some kind of HTTP API, etc. There's not a lot of exploration going on. The thing that does that just makes that call, and it either succeeds or it passes at making that call. And it's about configuration and writing some code. Generally, the easiest way to test it, write the code, hook it up to the real thing, and then see if it works manually. Maybe then effectively write a regression test, a test after test, to say, I don't want that thing to break. Now I've got it working. So here's a regression test that will basically break if that thing breaks. So in that case, I would tend to use test after, right? Treat that thing as a module that I need to basically get under test. And don't drive third-party code, right? It's not yours. Don't test drive against third-party code, right? If there's an API I need to talk to, don't do test-driven development against it. If I need to prove that my integration with that third-party code is correct, test after. I'm probably following a list of steps in a manual. I'm not exploring the solution. I'm just following the steps, right? Test after. And this problem space, I think, is why people get problems with TDD, because they see that, hey, for integration, test after is easier. For third-party code, test after is easier. So why don't I just do test after everywhere? It's because that's not the technique to be using there. It's not a technique to be used mainly in exploring our domain model. That's the main point we use TDD. Right? It's not, and people try testing the UI with it, and effectively they end up with these complex, Selenium suites or whatever, and it's not very TDD-like, right? So again, use TDD with what it's meant for, really, which is exploring a kind of domain model, right? And don't use it for things like integration or UIs. And that may mean you don't have 100% test coverage, and that's okay. All right, you want test coverage around the things that you're TDDing, and focus on what could break, and also focus on, hey, before I began this refactoring, I had this much percentage code coverage. After, I should have the same. All right, my refactoring should not have introduced basically untested branches. But overall, the thing to work on is the testing pyramid, right? This idea that the bulk of what I'm doing, presuming I have a typical line of business application where there's a reasonable amount of domain or business logic that I need to implement, I should basically try and focus a lot of my effort on the fast binary feedback. Gives me quick feedback, gives me a clear indication if it's right or wrong. So that's where I want to spend a lot of my time if I can in developer tests. But on top of that, I'm probably going to need some tests around IO stuff, and end-to-end. I want to automate, right, by doing effectively test after strategies, basically. I may want to do monitoring and alerting in production systems to give me feedback, particularly in modern distributed systems. It's almost impossible for you to predict all of my edge cases. So actually what I want to do is basically monitor and alert, make sure I can get feedback that way. And I may want to do some manual testing. As you go up the pyramid and go further away, effectively longer to the time of feedback, slower feedback, more likely to be a waterfall model than an agile model. Therefore, we want less of it. And they are more fragile and more effort. So I want less of the things that are expensive and slow, and more of the things that are quick and fast. But that doesn't mean to say that I don't need any of the things at the top where I can factor them out completely. It's just there may be useful ways of doing stuff. Right. Okay. I'll quickly talk about clean architecture, almost at the end. So that's kind of most of the testing coverage. So clean architecture is a way I find very useful to structure my code to succeed at TDD. So clean architecture is what Bob Martin named effectively a synthesis of various models that exist out there, most famously ports and adapters, sometimes called hexagonal architecture by Alistair Coburn, boundaries controllers entities by Ivar Jakobsen, and onion architecture by Jeffrey Palermo, right? And he synthesized all of those into one model. Here's the idea. There's a layered model. The central layer are entities. So what are entities? Entities are state and behavior that depends upon that state. So the class has some state. They have some methods who depend upon the state, which is part of my implementation as that class. Those are my entities, right? The typical things in the model that have some state, and I save it away and have rules on it. Outside that basically is the use case or application workflow. So my entities handle really some state and behavior, but generally to do anything useful, a user story or a use case, some acceptance criteria, I have to combine more than one entity. So a use case lets you do that. Typically implemented quite often what's called a service layer, or sometimes basically the command pattern by something like a mediator. And that's a way effectively of you saying, hey, I can encapsulate this idea of a business transaction, which calls the entities. A layer outside that, which tends to be framework based, which says I need to do IO, need to get work in, I need to basically save results out. And a layer beyond that, which is the actual IO device, which you're not actually writing. Green is typically quite often third-party frameworks in most cases. So your web framework you're using, your ORM or other mechanism you're using to save stuff to the database. And the key idea really here is what we call depends inwards. That is, that things in the outer layer can depend on things in the inner layer, but not vice versa. So your controller can't talk directly to your entity. It has to use the service layer to do that. It must create a command or instantiate your service layer and say, hey, please carry out this work for me for this use case. Changing the direction of travel of that, you can look at it this way. I effectively have some entities. There's an interactor in front of them, which basically mediates the conversation with my boundary layer, which basically is how I get requests in via a request. I've got a model request model because I can't expose the entity directly outside. So effectively I have something like a DTO perhaps, which says, hey, I get some request in, I get some parameters on my HTTP call, for example. I turn them into something I can actually program and actually work against, give them in the boundary layer to your controller method. It then says, spin up a mediator, ask it to do some work with the entities. It may need to talk to the database, so that interact will also talk to some kind of entity gateway and say, get values out of the data store. They in turn have a kind of gray model as well, really. And at the end, when I'm finished, I have a response model back, right? Now, you can TDD quite effectively against use cases because they are the acceptance criteria. Now, sometimes you may want to TDD against entities. And Kent Beck has this thing called gears, which is very much misunderstood. But gears is kind of like when I'm driving in high gear. I can't remember whether Ukraine is a country of manual shift or whether it's automatic. Same when you're in manual, right? You know, I'm driving in 5th or 6th gear. I'm on the straight line on the road, etc. Everything's good. That's me driving basically with use cases. Sometimes it gets a bit sticky. I slow down. I have to navigate. I want to drop down to first or second or third. That's me TDDing against entities, right? Generally, try and do as much TDD as you can against use cases. It's fast and it's a very effective way of doing it. And tend to treat the entities as implementation details, but you can drop to entities if you need to. Your X unit is effectively just another interface adapter. This is the same level as your controllers, X gateways, or presenters, in that it drives those use cases just as they do. So you can see this model is a representation of that. Got my X unit framework. I write a test in my X unit framework. In my setup step, I build up my request model, the things that I need to establish in order to call my system. I then tend to talk to my interactor rather than my entities. So my command pattern, my service layer, whatever I'm using, it exercises the entities, right? And gives me a response back, which I can assert against. I may have IO dependencies at my interactor level. And so effectively, I may want to replace those with something that's fast. Here I'm showing using an in-memory database as opposed to effectively, you know, a mock or a fake, but it's the same principle. Okay. And that then looks a bit like this. We say we don't TDD against other adapters. We don't tend to TDD controllers and gateways and presenters in this model. They should be very skinny. If necessary, then they will be tested by any system tests that I do at the outside. And they can be very simple. Those system tests could be something for, like, if I've got an HTTP API, they could be me basically using curl and JQ, right? So they can be something simple that's repeatable, that effectively gives me confidence that the whole thing fits together end to end. All right. So let's review the fallacies that basically I want you to be aware of. Developers write unit tests, right? We know that basically the unit testing is a different practice from test after. Trigger for a new test is a new function, right? Actually, that's not what should be triggering us to write. It may end up being a function that we essentially are driving mostly in the test, but we could be actually driving 2 or 3 functions, right? That's not the unit of criteria. We're talking about basically looking into behaviors. Customers write acceptance tests. This is a problem for us because effectively they won't tend to basically use the software. We end up with developers maintaining expensive DSLs. We need to focus more on acceptance criteria from customers. Doesn't matter if you test first or test last, right? Test after is a very different strategy with very different properties that doesn't give you the same things that TDD gives you. And you want 100% test coverage of your code, right? We're looking at the wrong thing there, where we should be looking at basically 100% test coverage of things that are being TDD'd, right? The principles you want, sorry about that. Developers write developer tests, right? So think about these developer or programmer tests, where essentially it is the last edit you made that effectively is the defect localization that you're looking for, and you don't need to use mocks or substitutes for them, right? That should be 2 rather than 3. I'm not quite sure why my numbering's gone wrong. I was doing right in the tests. The trigger for a new test is a new behavior, right? So basically we say, what are the behaviors we want in our system defined by the acceptance criteria the customers give us? All right, that's what I want to do, is make the smallest step I can towards implementing that new behavior. Customers write acceptance criteria, right? Customers effectively write the acceptance criteria, and we use that to create the behaviors that we essentially use to write the tests. We only write production code in response to a test. We don't write speculative code, right? So and that tends to mean we will have 100% test coverage of our TDD work, but then not everything should be TDD. TDD is great when fast binary feedback makes sense. Typically, our model is what we're basically driving. It doesn't make so much sense in some other areas where different methods of getting feedback are probably faster. All right. So